Hey gang, welcome back to Mr. Allen's Math 30-1 class. Today we're going to be talking about the connection between logs and exponentials. We are going to do some transformations here, so we are going to pull back that unit. But this first little slide, I just want to talk about how are logs and exponentials, how are they connected? We already talked about way back up there in the previous lesson, or two videos ago. We talked about that they're inverses of each other. And remember that inverses, if they're going to be inverses of each other, note the inverse relationship, that they are switching their x and y's. They're reflecting over this line, y is equal to x, and all the x's and y's switch. So if we just want to recall a little bit about what an exponential graph looks like, and the reason I have this written over here like this is for the older graphs, but you could just write this as, using that base identity, this is log base 2 of x. We're going to look at these two because they both have a base of 2. We switch the x and y's. We solve for y on the other one there with the log, and then we're going to look at these two. So y is equal to 2 to the x. If I remember that correctly, remember you can take the 2 to the power of any number you want. There's no limitation there. My range, you notice that there's no plus numbers, there's no a's, there's no h's in this case, and my y is that typical graph that we had before. It has to be greater than 0. It has an asymptote here at 0, but that's what we had before. We had no x-intercept, remember, because it can't have y is equal to 0, so how can I have an x-intercept? And remember when I make my y-intercept, we make x equal to 0, so this is just 2 to the power of 0 is equal to 1, so this point is 1, 0. So I can graph that out pretty nicely. And then we have some other points. So 1, 2, 2 squared is 4, 3 is 8. Right there. Oh, that was a pretty bad exponential growth function. Then we're going to go back in time here. So we got -1 is a half, -2 is a quarter, and then 1/8 and so forth. Okay, I probably should go a little bit further there. But we have an asymptote here. Hard to draw these kind of lines in this program. Okay, y is equal to 0. You know, so it crosses over this point right here at 0, 1. Okay, so we have some key points there. Now what we're going to do is we're going to do the inverse. So actually, yeah, we could do the inverse. We could draw the inverse on this graph over here if you want to, or we can graph this in our calculator and then check to see how those relate to each other. But I'm going to hazard a guess that there's a few things that we can do before we start. Because we're switching our x's and y's, I can determine some of these domains and ranges because I knew the domain and range of the previous function. So my domain of the new function is technically the range of the old function, acted before the inverse. That's a greater than sign there. Okay. And then my range of this log function is the domain of the previous one. Which makes sense, okay? And then I'm going to switch my x and y's. So if this was 0, 1, this now becomes 1, 0. So this becomes an x-intercept. And because I didn't have one before, x-intercept-wise, I don't have a y-intercept for this one. And I switch my x and y's. So this y becomes an x. So it looks like I'm going to have an x asymptote, or a vertical asymptote this time, rather than a horizontal asymptote. So according to this information here, let's see what this looks like. I'm going to switch x and y, so I have some points on this graph already. So I have this asymptote of 0, x equal to 0. And we're going to start switching some points here. So this point was 0, 1, now it's 1, 0. Well, let's use a different color. Let's blue here. All right. This point is 1, 2. So now that's 2, 1. This point is 2, 4, now it's 4, 2. And this point is 3, 8. Now it's going to be 8, 3. So you get this general shape here. Now, if you were to draw the y is equal to x line here, you can kind of see it's being reflected across this imaginary line that I have here. Okay. Got some other points here, like this is -1, a half. Now it's going to be a half, -1. Oops. There's going to be -2, -2 1/4. Now it's going to be 1/4 -2. And then we're also, we're going to have this vertical asymptote right here. Get closer and closer to this axis. We'll never quite get there. So that's what our two graphs look like. All right. So knowing how the graphs start or how they look is going to help us with our transformations. Like if I were to sketch a graph and its inverse, if I can sketch one really easy, then the inverse should be pretty easy as well. So same thing with this kind of graph here. Also want to mention that previous graph, there's no invariant points for that previous graph because nothing crossed each other. This one could have an invariant point. Let's just double check. So what we know about this graph so far, the exponential one, is XER, and that means the inverse, which is going to be a log. Remember, the inverse is I switch the x and y's. So let's put that down here. So I switch the x and y's to do the inverse. So this is going to be x is equal to 1/3 to the power of y. Now, I switched the x and y's, but now I got to solve for y to do the inverse. So the solve for y, because it's in the exponent, is to change it to log form. Now to change the log form, no. So this puts x in there, this goes to the y. So this technically is my log. So my log of base 1/3 of x. That's my inverse. Okay. I think I had the inverse up here before. Yep, these are both the inverses of each other. Some things about this, like you should recognize that my x values can't be 0 or less. They have to be positive numbers, like into my log. So my domain here is telling me that everything has to be positive. You could verify that. You could try to take the log of 0 or a log of any negative number. It just doesn't work. You just can't do a log of a negative or a 0. Okay? It just follows the same logic. Like if I put a 0 there, that means I'm looking for 2 to the power of something to be 0, or a base to the power of anything to be 0. It just doesn't work. You just can't do it. So these things you can't do. You can't do negative numbers or 0. Okay, so the range of this new graph is going to be the same as the domain as previous because they're inverses. The range of the new graph, remember, or the old graph here, sorry, is just going to be greater than 0. That means the domain of this graph, which is x now, you switch the x and the y's, it's going to be greater than 0 as well. Okay. X-intercepts, everything's kind of the same. We have none here. That means we have no new nodes or no y-intercepts. Before, the y-intercept was 0, 1, but now this x-intercept is 1, 0. And the asymptote was y is equal to 0, but now it's x is equal to 0. So you're just switching your x and y's around. And I can graph this out. So there's my old graph. This is going to be my f of x graph here. -1 would give me 3. -2 would give me 9. Kind of much more because you're dividing by 3 each time. So 9 divided by 3 is 3. Divided by 3 is 1. Divided by 3 again is a third. Then a ninth, et cetera, et cetera. It's a much steeper graph than the previous one. And this is going to go on for an asymptote here. It's not going to cross. That's a mistake right there. And this is going to go up there forever. Okay. Now, if I were to do the reciprocal of this, not the reciprocal, the inverse of this, I'm going to switch my x and y's here. This point, let's just make this red this time. This point becomes that point. And sometimes it's kind of hard to see what happened, but we got -1, 3. So 3, or -1, 3. So 3, -1. Oh yeah, that makes sense. Okay, 3, -1. And then -2, 9. So negative, or 9, -2. Okay. So these points were connected together, so it's going to look like that. Then the other part of this graph is going to go up this other way. So 1/3, 1/9, et cetera, et cetera. Up like that. Now you can see here, there's a point. It's very poorly drawn, but there's a point here that's the same. Now that point is when you have log of the same base, right? The log of the number that happens to be the same base. So like in this case, it'd be log 1/3 of 1/3. Or these two things would be the same. Actually, that'd be 1. So these here would end up being the same points. And they are invariant points because you're switching your x and y. So whatever point this happens to be in this case, when you switch your x and y's, they just end up being the same. So there's an invariant point in this one. Now let's just write that invariant. Okay. So knowing that, we can determine certain things about these because we know that these graphs are inverses of each other. So mathematically, I can always determine the inverse of this. But you can think about this here. This point just happens to be on the graph of f of x log base c of x. So I know that this point is on this graph. So I'm just going to mention that. That goes with this graph. And then this new point, 4k, is on the inverse of this graph. So they want to know what the value of k is. So I'm going to look at this graph here. I'm going to look and say, what is the inverse of this equation? So this originally is y is equal to log c of that. If I do the inverse of this, this is c to the power of y. Oh, sorry. I'm going to switch the x and y's first, I should say. Let's get rid of that. Let's switch the x and y's. So if I switch the x and y's here, I get x is equal to log base c of y. And then I would change it to exponential form to get y by itself. So c to the x. So that's what this looks like originally. And it just makes sense because that's what we had up before. Now, what's it saying is that if I put a 4 in here, I'm going to get a k out. So if I put into this equation a 4, I'm going to get k out. And I want to know what this k is. But the problem is if I'm going to solve for k, I didn't know what my c value is. So I'm going to use this other information here to find out what my c value is. This is just saying that if I put 1/5 into this equation, I need to get -1 out. Okay, makes sense. Now, to figure out what c is, that's inside this operation. It's log base c, and I can't really just divide anything over. I can't get c by itself here. So I'm going to just quickly do what I did over here, change it to exponential form. So this just says c to the power of -1 is equal to 1/5. And now I can solve for c. So -1, I can change that to 1 over c. And I can see that c is 5. Now I can take that answer that we just found here. I can put that way over here. So now this is a 5. Right? So 5 to the 4 is equal to k. So I can say k is 625. There we go. So like when I think of these problems, I'm thinking, okay, let's start off over here. Figure out what are we missing? What do we need to solve the question? Then we have to go back here to find what we're missing and put it back in here. You could, if you look at it logically, you probably think, okay, that's what I want to do. So you could have started over here, knowing that you had to find c, and then go over here and just plug the c into this equation. And you could have the 5 in here all the way through, and you could do it that way. It's up to you. I just like to start over here thinking, okay, this is what I want to do. I want to get k. How do I solve for k? Well, I got to do this, but I need to find c first. Same logic here. It's like, well, in this case, I just want to find the inverse. So I'm just going to put a y there instead of f of x. Remember, f of x and y are interchangeable of each other. Then you're going to switch your x and y's. Okay, so let's switch the x and y's. That's what the inverse is saying, right? X is equal to y, or y is equal to x. So this is going to end up being x is equal to, that's what we did over here. We switched the x and y's. Nope, that should be a y now. Okay. And then what we're going to do with that is we're going to try to solve for y. But you notice that the y is inside of this log. And I can't just divide the log 5 over and accept that because it's trapped in there. So it's just like I can't divide a 2 out of a square or something. If it was 2 squared, I can't just, or 2 to the power of x, I can't just divide the 2 out because it's stuck inside that exponent. It's stuck inside of this operation. So to get it outside the operation, just like we did here, we got to change it into an exponential form. So we're going to take this, we're going to change it to exponential form. But before we do that, we have this -4. We haven't seen this -4 before, this new piece right here. To change it in exponential form, I can't have anything in front of the log, and I can't have anything outside the log on the same side as the log. So I'm going to have to move that 4 over to the other side first. So it's going to end up being a +4 here. I'm going to try to write this a little bit nicer. Okay, now I can change it into exponential form. So I can say that this is my base is 5. So this is going to be 5 to the power of something. All right, we're going to switch these two pieces. Like this whole side and this y + 2, we're going to switch it to. So this is now 5 to the power of x + 4. And I'm going to switch it with the y + 2. And now I can see that this, if I wanted to make y by itself, is minus that 2 over. And there we go. So now we have this in exponential form. And I can analyze that and can say, okay, this graph is translated down 2, it's moved left 4. Or I can look at the log and say, think of the same thing as the log. This graph has moved left 2 and moved down 4. So I can do the same thing, transformations, that we've done before. Okay, so we do the same thing here. What's the inverse of this graph? So the inverse of this graph is you're going to switch the x and y. So y is equal to x. So imagine this was a y originally, so that becomes an x. And then 8 to the 3y + 3. So I want to determine the inverse, so now I solve for y. Now the same rule applies. This +7 shouldn't be there. So I'm going to have to move that +7 over to the other side. And because I'm solving for the exponent, I'm going to change it to logarithm form this time. So you're going to do the inverse. Essentially, that's what we've done already. We're going to switch the x and y's here. So this is log base 8. And then I'm going to switch these two things. So now I have x - 7 in here, and this is 3y over here. And then I can just isolate for y, just divide that 3 over. Now, when I divide the 3 over, it doesn't go inside the log. It's because that log is an operation. I can't get it inside that log. It's not allowed to do that. So that divide by 3, I could just stick in the front. And we have that. Now, in future courses, we can actually move that 1/3 into the log somehow, but that's a different log law. So I can't just times that in or divide it in. It becomes an exponent. This is a weird little rule that we're going to learn when you get the log laws. Okay, so the equation of the vertical asymptote. So let's determine the equation of the vertical asymptote for this guy. Now, what we know about the original graph, log base x, or c of x, the vertical asymptote, if you go right to the very top of this lesson, the vertical asymptote is x = 0. It's just the vertical line right on the y-axis there, because the original exponential graph had a horizontal at y = 0. So we switched it to, rather than y = 0, x = 0. So we just want to know, how do we move this? What happens when I apply these transformations to it? How does it move this vertical line on the y-axis? Well, what we know, because it's on the vertical axis, on the y-axis right now, that any stretching or reflecting is not going to move this point. So this 2 really is not going to do anything with my vertical asymptote. It's going to stretch the graph out and make it look different. But it's not going to change this vertical asymptote. So this 2 is not going to do anything. This negative is not going to do anything, but the way this is written right now, we're going to have to modify this to just simplify our problem a little bit. So we're going to factor the negative out. And we always have to do that. We always have to factor that b value out. And when I do that, I get this. I get this x - 6. And this is going to, rather than saying that this moves left 6, is actually moving right 6. Yeah. So the negative, again, like I was saying before, the 2 and the negative are not going to change anything about the vertical asymptote, because it's straight up and down, and I flip it over, it's still straight up and down. But when we move it right 6 units, And by moving this right 6 units, I just moved my asymptote right 6 units. So this, let's just highlight that. So this point here, this says here, is going to be right 6 units. Now the 5 is up 5 units. But a vertical line moved upwards 5 units. It's still just the vertical line at that point. So that up and down doesn't really do too much. It's the side to side we have to worry about. So by moving it right 6 units, my asymptote is now x equal to 6. Okay. We're almost done this section here. We'll do one more. What's the domain and range of this new graph here after the transformation? So what we remember about this graph here, remember it's the inverse of it exponential, that the domain of this graph is originally has to be greater than 0, XER, right? And the range of this graph is just YER. Okay, so after I do these transformations to it, let's just fix this transformation first. So this -2 hasn't been factored out properly yet. So this turns to a +4 out here. Okay, so based on what we have here, I know this is a reflection in the y-axis. So I'm just going to write that down, a reflection in the y-axis. A horizontal stretch. A horizontal stretch of 1/2. Remember that one has to be the reciprocal. And then I'm doing these translations here. So translation, but not 8 units to the right, but 4 units left and 4 up. Okay. So now we know what's happened to this graph. Let's figure out what happens to our domain and range. So I'm not too concerned about this piece because that doesn't change our domain and range of the original graph. Okay. So a reflection in the y-axis is going to change the graph to look like this originally. That's what this graph looks like. If I do a reflection in the y-axis, the graph is now going to look like this. So my domain has switched sides. So that means I know that this here in my domain, whatever it happens to be, is going to be a less than sign now. It's going to be less than whatever the vertical asymptote happens to be. This doesn't have to be, here it had to be x equal to 0. But this doesn't have to be. We don't know what that is yet. But it's translated, like we were talking about before. My vertical asymptote moves, if my graph moves left or right, my vertical asymptote moves left or right. So I moved 4 units left. So that this point is actually -4. Okay. Moving up and down doesn't change that part. Let's just see. Now the up and down parts, oh yeah, sorry, squishing also doesn't change too much because originally, remember what you had to do. You had to stretch on the 0 first. So 0 times 1/2 doesn't do anything. Then I move it side to side. Okay. Now the range only changes all the vertical stuff. The only thing I've done vertically in this case is moved it up 4 units, but the graph was all the y values. If I move everything up 4 units, so still all the y values. It hasn't changed too much. It hasn't changed at all. So we're done with that. Okay, so I'm done here. Let's stop that lesson for now. We'll come back. We'll do some more transformations of exponentials and more transformations of logs. This is pretty easy. It's pretty quick refresher. Really not much more than what we did the previous chapters. So we'll see you next time. Later.